Hello all, hope you're doing well. So this video is in continuation to my previous video in which I discussed about normality, the equivalent weight, and pH was a pending part that I'm going to discuss in this video. So pH numericals, we are going to discuss a little bit about the formulas we discussed in my previous videos also. So we can understand this concept better from the numericals. So let's discuss this. In this question, calculate the pH of a 10 raised to the power minus 3 molar solution of barium hydroxide if it undergoes complete ionization. So Kw over here is given, that is ionic product of water into 10 raised to the power minus 14. So remember this H positive ion, product of this H positive ion and OH negative ion, that is equal to Kw, that is 10 raised to the power minus 14. So 10 raised to the power minus 7 into minus 7, for this is for water, right? So anyways, coming back to this question. Now we know that 1 mole of barium hydroxide from the formula itself gives 2 mole of OH negative ions. So if we need to calculate the concentration, you call it as molarity or normality like any concentration. So anything that we can take. Concentration of OH negative ions, if we need to calculate, so we need to multiply 2 into concentration of barium hydroxide. So it's very similar to what I said in the last. Normality is equal to molarity into n factor. So n factor over here is nothing but 2 because it's a diacidic base, right? So 2 into concentration of barium hydroxide, and the concentration over here given is 10 raised to the power minus 3. So 2 into 10 raised to the power minus 3, that's the concentration of OH negative ions. Either you do with this formula or like this, it's up to you. So we know H positive ion and OH negative ions product is equal to Kw. So we need to find pH. That means they are asking us H positive ion. So H positive ions is equal to K, concentration of H positive ions is equal to Kw divided by OH negative ion concentration. So Kw is given 1 into 10 to the power minus 14. OH negative ion we just calculated, that is 2 into 10 to the power minus 3. So if you calculate this, minus 3 will go above and this will give you minus 11, and half is nothing but 0.5. So we'll write over here 14 minus 3 is 10 raised to the power minus 11 and half 0.5. So we will get this. Now if we talk about the pH calculation, we need to still find the pH, that is given as minus log of H positive ion concentration. So H positive ion concentration that we have calculated, that is 0.5 into 10 to the power minus 11. So what do you need to do over here? You can take this as 5. I can even write like this, 5 into 10 to the power minus 12. That makes sense. I just removed this decimal. So now according to the formula, if you remember this, like this formula, if you remember, log 10 raised to the power x is equal to x log 10. Log 10 value is equal to 1, correct? So I'll be taking this number, right? This number over here, minus 12. So this will become because I've written over here log 10 to something 10 raised to the power x will become x log 10. So I'll be writing now over here only for this value minus, right? So I'm applying this formula. So this will become minus and minus 12 log 10, right? Minus log 5, I'm going to keep like this. So this will become 12 only because log 10 value is equal to 1, minus minus will become plus, minus log 5. Now what is log 5 value? That you can you can remember certain log values. Like if it's not given in the question, you can remember certain. Otherwise, most of the time they will give in the question. So log 5 value is 0.698. So 12 minus 0.698. So if you subtract it, this will give you roughly 11.302. That's our answer. This is the pH, right? We are calculating pH. Now, if you go to the next question, this is a simple one. Sometimes we should do simple questions also. So, calculate the pH of the following solutions, assuming complete dissociation of HCl. So, over here, first is 0.01 normal HCl. Then we have 1 normal HCl. So if you talk about the first one, H positive ion concentration is equal to HCl concentration, and this is 0.01, or we can even write 10 to the power minus 2 normal, right? So for HCl, normality is equal to molarity. Why? Because N factor over here is 1. For equivalent weight, it's going to be same. So now pH, if we are calculating, minus log of H positive ion concentration minus log of 10 to the power minus 2, again do the same thing. So minus, this will become minus 2 log 10 according to the formula which we discussed. So this will become 2 log 10 value is 1, right? Then if you go to the second question, again for HCl, the molarity is given 1, so we can take it as 1 normality also, because molarity and normality is same for HCl because it's a monobasic acid. So pH is equal to minus log of H positive ion concentration. So this will become minus log 1, that's equal to 0. That means it's a strong concentration according to the pH scale, right? Next, we will go to another question. 0.01 mole of sodium hydroxide is added to 10 liters of water. How will the pH of water change? Now for the calculation I've done prior to these questions so that we can save some time, since I don't want to make long videos and I don't want to chit chat so much, we can save time. So when it comes to studies, I don't like, you can say, I don't want to waste half of my video in talking, right? I want to teach, and that is most important when it comes to exams. I know most of the people, during their exams or before the exams, they will be like, you can say searching YouTube videos or any type of content which can explain them better, or they are able to understand. So some will be able to understand because you need to have a prior knowledge in order to understand these concepts. So the prior knowledge is given on my channel. You can actually search and you can listen to it and understand it. Okay, coming back to this question again. 0.01 mole of sodium hydroxide is added to 10 liter of water. How will the pH of water change? Now, first thing, they have given mole. We'll try to calculate the concentration because we need concentration for pH, right? And they have given volume also, so why not, right? For pH we need the concentration, and they have given both the things for calculating concentration. Molarity I'm talking about. They have given moles, they have given volume. So concentration of NaOH is equal to 0.01 divided by 10 liters. So you don't have to do anything. It's moles given. It's not even weight given that you need to calculate them into moles first. So this will be 10 raised to the power minus 3 we can write. It's molarity. And since wonderfully our sodium hydroxide is NaOH, NaOH means it's monoacidic base. Its n factor is 1. So for this, molarity and normality will be same, so no problem. So when it comes to pH numericals, we always need to take normality, because normality is something, it has equivalent weight in it, and that is something which is defining acid base neutralization. So we have to take the normality in that. Then we come to OH negative ion concentration, that we have as 10 to the power minus 3 molar. That is okay. Now coming to the same ionic product, Kw. So Kw we know that is equal to 10 to the power minus 14. So product of these two ions is equal to Kw, and we are calculating over here H positive ion because we need to calculate pH. Similar question we did in the very first question, I think we did similar to this. So 1 into 10 to the power minus 14, OH negative ions is 10 to the power minus 3. So we will get 10 to the power minus 11, 14 minus 3 is 11. Then we come to pH minus log of H positive ion concentration minus log of 10 to the power minus 11. So this will be equal to 11 only. So I'm not writing it again. Minus will cancel. It will become plus. Log 10 values is 1. So we can say, now coming to the question, what they said, how will the pH of water will change? How will the pH of water change? So pH of water we know that is 7, right? So its pH increases by 4. So 11 minus 7 is nothing but 4. So that's the answer. So we can discuss one more last question. Then we'll end the video. Calculate the number of H positive ions present in 1 ml of a solution whose pH is 13. So if you can see, pH is minus log of H positive ion concentration. So I can say if pH is equal to 13, so H positive ion concentration will be 10 raised to the power minus 13. This is mole per liter. That's a concentration. So we can say, like, first we need to understanding, we have to calculate the number of H positive ion. And remember, like I missed this part, number we need to calculate. When it comes to number, you need to remember Avogadro constant. Again, you can see my mole concept videos in order to understand it better. So number of H positive ions present in 1 ml of solution whose pH is 13. So we need to consider, we need to calculate the number of H positive ions. We know pH is 13. We need to calculate, we need to consider even 1 ml in this, right? So how we will proceed? So we figure it out that the concentration of H positive ion is 10 to the power minus 13 mole per liter, right? So now over here, mole of H positive ion present in 1 ml. So this will be 1 ml, or you can say 1000 liter, okay, because mole per liter we said, no, we if the 1 ml, if you convert it into, where it is, so 1 ml, or according to, you can say 1000 liters, right? We need to consider that, not 1000 liters, like 1 liter we have to consider. So 1 liter is equal to how many ml? 1000 ml, right? So this concentration is in liters, so they are talking about only 1 ml, but we need to consider liter, like 1 liter is equal to 1000 ml. So 1000 ml means what? That is going to be 10 to the power 3. So moles of H positive ions present in 1 ml. But how many moles will be present in 1000 ml according to the liter? So this is 10 to the power minus 13. For 1 ml, it's fine, 10 to the power minus 13. But for 1 liter, it will be 1000 ml. So you have to divide it and you will get 10 raised to the power minus 16. This 3 will go above and it will become minus. So minus 13, then minus 3, this will become minus 16. So these are the modes of H positive present in 1 ml. Okay, in per liter it was minus 13, but for 1 ml it will become minus 16. You multiply by 1000. That's what we are doing over here. Now we come to the number of H positive ion in 1 ml. So mole in 1 ml into Avogadro constant. Wherever we are asked about the number, we need to consider about the Avogadro constant for sure. So mole in 1 ml, that we just calculated, 10 raised to the power minus 16, and Avogadro constant 6.022 into 10 raised to the power 23. So now if we subtract it, this will be roughly 6.022 into 10 raised to the power 7. That's the answer. Number of H positive ions in 1 ml. Right, so hope you have understood these numericals and they were helpful, and you need to practice a lot. So keep practicing, keep learning, and thank you for listening to this video, and please subscribe, like and share my videos. Share with your friends if it was helpful. Thank you.